Alright, I was continuing with this problem so I could figure out what time the balance decreased the fastest. The only one I've done so far is that I found the rate of change to be negative 53 from days 1 to 6. From days 6 to 16, let's see, the change in the y would be 285 minus 210 over the change in the x's would be 6 minus 16. That gives me a negative 10 on the bottom, and on the top I'd end up with 75. So that would mean a negative 7.5 rate of change. On the next one, I actually have my change in my y's being 0. My change in my x's does give me a value, but since it's 0 over negative 6, I still end up with a rate of change of 0. On the last part from day 22 to 30, I have my change in y's being 210 minus 175 over 22 minus 30. This ends up giving me 35 over negative 8. Now that corresponds to, let me go ahead and clear that. 35 divided by 8 gives me 4.375. So I'd have negative 4.375. Determine the time the balance decreased the fastest. Well, that would be back up here between days 1 and 6. Between days 1 and 6, I have the balance is decreasing at a rate of negative $53 per day. Another way you can display data is by looking at the graph, and what we can do to find out where the greatest change occurs is to look for actually the steepest slope. So right here I can tell the greatest change is taking place because it has the steepest slope. And now we're getting ready and I'm starting to use that word slope. And slope is a great way of describing that is the vertical change, which would be your y's, over your horizontal change, which is your x's. So the change in y over the change of x is what I kept describing in the last problems, and that's also known as rise over run. When we're looking at a picture, I'm going to talk about rise over run. The way you're going to find the slope of each line is you've got to find 2 points, okay, just 2, where it crosses exactly at a dot that you can tell. So this one and this one right here. We're going to talk about the rise over the run. So how far does it rise to reach this point up here? So what I could do is I could sketch in this line. How far am I having to climb until I get to the same height as this other dot? Well, I'm climbing 1, 2, 3, 4. See the 4 humps. So there's a rise of 4, and then there's a run of 1, 2, 3. A run of 3. So I can describe this slope as 4 over 3. The rise over the run. Now I'm going to talk about, well, what if you would have used different points? So maybe you use this point and this point down here. Well, you still get the same answer. Well, how do you get from this point to this point? Well, you could start down here, or you could also start here. And you could say, well, I'm going to go down 1, 2, 3, 4. When you're going down, that's actually expressing a negative value. So your rise would actually be a negative 4, where your run, 1, 2, 3, would be a negative 3 because you're moving to the left. Well, notice that negative 4 over negative 3 is equal to 4 over 3. So you get the same slope no matter which way you do it.